In this video, we'll look at question 41 from the 2017 exam.
So we are given a triangle PQR, and we know two lengths of its sides. QP equals 4x, and the length of QR is 8 minus 3x. The angle between them is 60 degrees. And we're supposed to find the maximum area this triangle can have, depending on x. So can you think of a formula we could use to find an expression for the area, given two sides and the angle between them? This formula is going to be very convenient for that. 1/2 times the product of the lengths of the two sides times the sine of the angle in between. And for us, it takes this form. And because sine 60 is √3/2, we get 1/2 √3/2 is √3/4, and the two expressions in the parentheses. Finally, the area in terms of x is √3 times 8x minus 3x squared. Remember, we need to maximize this expression. So what do? We need to differentiate with respect to x and set that equal to 0 and solve that equation, given by the condition that the derivative must be 0. That is, we find the stationary points. So that needs to be 0. Let's do it on the side here. dA by dx is √3, that's just a constant that stays. 8x differentiates to just 8, and 3x squared to 6x. And that needs to be 0. And the only such solution is 4/3. And plugging in back into the original expression for the area, √3, 8 times 4/3 minus 3 times that squared, which is 16/9. And when we multiply and subtract here, we get 16 √3/3. And that's the maximum area we can get by a suitable choice of x. And in the exam, there was option D. You might have noticed that I was a bit lazy with my stationary points here, in that I just found a stationary point and kind of assumed that it would be the maximum, which doesn't have to be the case necessarily. And in the exam, because they're asking about the maximum, and this is the only stationary point which we can find, it probably is going to be the maximum. Generally speaking, we should be careful and always check either with the second derivative. And as we see that the second derivative for our function is negative everywhere, that means our stationary point has to be a maximum. Or we can just check with our intuition in this case, because as x approaches 0, we see that the area would be 0 because QP, the length of this side, would approach 0. And equally for large x's, QR would tend to 0. And if for both extremes it tends to 0, the area, but it has to be positive somewhere in between, then the only stationary point between the two extremes has to be a maximum. The shape of the function has to be approximately something like this, with a maximum here.